Alright, this is part 2 of our subtraction of integers examples. Here we have, for example, to use a pictorial model and a number line to model the expressions. C is -8 minus 5 and D is -6 minus 9. Let's go ahead and begin with expression C, and just as before we'll begin modeling it with the integer circles. Now my first digit in my expression is -8, so I have to show 8 negatives. And I do that by drawing 8 circles with negative signs inside of them. Combined, they equal -8. The next part is, in my expression, says to subtract 5 positives. But if you look here, all I have are 8 negatives. I don't have any positives. So I need to figure out a way to bring some positives in there. And the way to do that is by using zero pairs, because zero pairs come with a positive and a negative that are combined together. They're like buddies, they travel together. And remember that together a positive and a negative equals 0. So if I have 8 negatives here and I add 0 plus 0 plus 0 plus 0 plus 0, I still have -8, because you can add 0 all you want, it won't change the value of your original number. So in this case, I added 5 zero pairs because I know inside those zero pairs there are 5 positives that I'll be able to take away in the next step. So let me go ahead and redraw this picture now, putting all my negatives in one row and all my positives in another row. When I do that, I get this next picture. Here I have the 8 negatives plus the 5 that came with the zero pair all in one row. Then I have the 5 positives that came with those zero pair also in the next row. Now I want to try doing the next part of my expression, which is to subtract 5 positives. So I ask myself, do I have 5 positives here that I can take away? And sure enough, right here on the second row, I have 1, 2, 3, 4, 5 positives, the exact number I need to take away or subtract. So I'll go ahead and do that. I do that in the next step here. I went ahead and subtracted the 5 positives, and I bring down whatever remains. In this case, I have a total of 13 negative circles, which is equal to the amount of -13. Therefore, -8 minus 5 equals -13. One way to verify that answer is to try it with a number line. So I'll begin as I did before. I rewrite my expression, -8 minus 5, then I'll create a number line. In this case, my number line goes from -14 to +2. Notice, in order to save space, I only marked every other number, but I do have a space on my number line for each integer. So I have all the evens from 2 to -14, but I have all the integers from 2 to -14, including the odd numbers, marked on my number line. Now to begin making my number line, or sketching my number line, I take the first digit, or the first value in my expression, which is -8. As always in a number line, I start at 0 and I go to the value of my first digit, in this case 8 steps in the negative direction. That's my first value. Now I'm going to subtract, or go even more left, 5 spaces. So I'll go ahead and do that in my next illustration. Here I have the -8. Now I am subtracting 5 more spaces in the same direction. To get my answer, I basically just redrew this whole sketch again with one line that combines the two, and in this case I get a line that goes all the way from 0 to -13, and this matches my answer I had from above, -13. Now that we practiced this, let's try to go ahead and go on to example D. Example D on the right hand side is -6 minus 9. Once again, we'll model this first one using the integer circles. So my first digit is -6, so I have to somehow illustrate -6. I'll do that by drawing 6 negative circles. And here I go. I have 6 circles with negative signs inside of them. That equals -6. The next part of my expression asks me to subtract 9 positives. But if I look in this picture I have here, I have no positives whatsoever. So to figure out a way to bring in some positives so I could subtract 9 of them, well, once again, I'll call on my friend, the zero pairs. In this case, I'm going to bring in or add 9 zero pairs, because within those zero pairs are some positives that I can use to fulfill my expression. So I bring in 9 zero pairs. I had my -6, I added 0, plus 0, plus 0, plus 0, plus 0, plus 0, all the way, and I still have negative 6, because remember, you can add 0 all you want, it won't change the value of your expression. Now I'm going to go ahead and redraw this picture so all my negatives are in one row and all my positives are in another row. When I do that, I get this picture. I have a row of the 6 negatives I started off with, plus the 9 more that came with my 0 pair. Then I have the 9 positives that also came in those same 0 pairs. My value is still negative 6. Now my expression asks me to subtract 9 positives. Do I now have 9 positives that I can subtract? I sure do, this whole second row down here. So I'll go ahead and subtract those now. I simply just scratch them out, mark them out, however you want to describe it. I get rid of them, and I bring down whatever remains. In this case, I have 15 circles with negative signs, which equals negative 15. Well, let's see if this answer makes sense, and the best way to check that is to do it with a number line. So I'll go ahead and begin again. My process this time is the same as before. I'll write down my expression, negative 6 minus 9, and I'll create a number line. In this case, my number line is similar to the one I did before, in which I start at 0 over here on the right and continue down to the left-hand side with my negative numbers, counting by 2, but leaving spaces in between for all the odd integers as well. Now I'm going to graph my first line segment, which goes to negative 6. So I start from 0, like always, and I go negative 6 spaces, which is 6 spaces to the left of 0. I do that, and I get my first line segment. From here to negative 6 is negative 6 units. Now I'm going to subtract, or go back, 9 more units. So I start just right at where I left off on the first one, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 more spaces to the left, and I stop there. The place where I end up is my answer. And just to make the answer a little more explicit, I'm going to go ahead and draw a second graph that has the whole length of both those segments combined. And it becomes very obvious that the length of my 2 lines equals negative 15. So there you have 2 more examples of how to use integer subtraction.